Question number 5. The function f is a twice differentiable function for all x, and we were given that f0 equals 0. Values of f prime, derivative of f are given in the table. So here, question number A, for x larger or greater or equal to 0, the function h is defined as this. Find the value of h prime pi. Show the work that leads to your answer. So we are given hx, and this is an integral with a varying limit. 1 plus f prime t squared dt. Now let's differentiate hx, so this becomes h prime x. Now the limit here is just x, so we don't have to worry about using the chain rule. So we can remove this integral and replace t with x. And remove the dt. Okay, so h prime x equals to the square root here. Now let's substitute pi. We're being asked to find x equals to pi. H prime pi equals to 1 plus f prime pi squared. Okay, we were given several values of f prime, and f prime pi equals to 6. So it is 1 plus 6 squared, which is 6 squared is 36, plus 1 is equals to 37. Okay. Question B. What information does this provide about the graph of f? So this function might look familiar because it is the arc length formula. So what this tells us is that this function, or this value here, goes from 0 to pi. So this is the arc length of the function from 0 to pi. So let's say we have this function, random function f gx, and it goes from a to b. Now the arc length for this function gx from a to b can be written as this. This is the arc length formula. So 1 plus f prime x squared. Now this is exactly the same. A equals to 0, so we start from 0, and then b equals pi, so we end at pi. So this is the arc length of the f function. Remember that this is f prime, modeling the arc length of f is the arc length of f x from t equals 0 to t equals pi. Question C. Use Euler's method starting at x equals 0 with 2 steps of equal size to approximate f2 pi. Show the computations and lead to your answer. So first we have to figure out what is the step size. So we start from 0 and we want to approximate a value at x equals 2 pi with 2 steps of equal size. So this means there's 2 steps. So first we go from 0 to what? To 2 pi with 2 steps of equal size. So naturally the value is pi. So 0 to pi and then to 2 pi. Okay, so now let's use Euler's method. Okay, so what Euler's method state is that, let's see, f0 is given as 0, and f pi So f pi is approximated to equal f0 plus f prime 0 times the step size, which is 2 pi. So first we used step size number 1 pi here into f pi, and we approximated as this formula, and we know that f0 equals to 0, and we know that f prime 0 equals to 5. Okay, this is not pi, this is just pi. Okay, this is just pi, not 2 pi. So f prime 0 is equals to 5 times the step size, which is pi. So f pi can be approximated to 5 pi. Now let's approximate 2 pi, which is what we want here. f2 pi is equals to the last step size value, which is pi, approximated pi, plus the derivative or the slope at the last value, times again the step size, pi. So f pi is approximated to 5 pi plus f prime pi, which is 6 given here, times pi, which is equals to 11 pi. So according to Euler's method, at f2 pi at x equals 2 is approximately equals to 11 pi. Okay, question D, the last question for question 5. Find this integral and show the work that leads to your answer. So this question is kind of not related to question 5. So this is an integral. We are trying to find this t plus 5 times cosine t over 4 dt. Okay, so how do we find this integral? Now, if we use substitution, there's not much way, and partial fractions will help here. So let's try to use the by parts method. Okay, so we have t plus 5 times cosine t over 4. So first I would like to write v here equals something, v prime equals something, u equals something, u prime equals something. So we have to find something from v prime, and for u into from this equation, the original one. So if we pick u as t plus 5, then if we integrate u, we would get just 1, and it'll be simpler. If we take v prime to cosine t over 4, then to find v, we can integrate cosine t over 4, and we would get sine something. Now sine times u prime, which is 1, would make integrating very much simpler. So let's follow this. So first v prime times u. Okay, so t plus 1 cosine t over 4. Then we times u to v, and then we minus, subtract v times u prime. Okay, so can write the original equation as v prime u dt equals vu minus integral vu prime dt. Okay, like I said, if we let u equals t plus 1, t plus 5, then if we differentiate u, we would get 1. If we let v prime equals cosine t over 4, we would get 4 times sine t over 4. Okay, so this formula is the by parts formula. It could be different in textbooks. So if we substitute our values into this formula, so this part is equal to this part, so we want to find these values, v and u, so it's, can rewrite this, cosine t over 4 dt. V times u is equals to t plus 5 times 4 sine t over 4, which we integrated. Now we minus the integral of v times u prime. V is equals to 4 sine t over 4 times 1 dt. So goal of by parts is to go through all this and find an easier function that can be integrated. And usually it can be times 1 or a constant, and we could find the integral of this. So we can leave that out. Minus this function, which is with cosine t over 4, and 4 times 4 is 16, and we have a negative, so it's plus 16 cosine t over 4 plus c. So this is the by parts method.